Students, we can start. So we'll continue with our lab computer manufacturing to study how to create the G code. In this case, we will write the program for this prismatic element. So we will use in this case the surface milling for the beginning as usual in order to remove some overstock. And we will see today new function is the plane milling. So in order to remove the material in the high portion, so for the roughing operation is the mostly used. In order to remove, you see the depth is the high here, and this is the very useful operation in this case. Now if you mention that if you see that we are now in the modeling, we are the modeling environment with the all functions here in the part navigator. As usual, that we will go from the modeling to the manufacturing for the beginning. In this case, we have the two options. The first option is you can select from application and go to the manufacturing, or here select the file and go to the manufacturing. So you have the two options. In this case, let's select application and select the manufacturing here. Now you will be obtain the manufacturing the environment with the several tools like the create tool, geometry create operations, and so on. As usual, we will start to define the geometry blank and coordinate system for this operation. In order to do this, here you will select here the geometry view. It's a short one. Select the geometry view and you will be obtained here in the part navigator. So these two options. For the beginning, you have to you have to create the 0 point of the workpiece. Double click to this coordinate system, and you see the dynamic coordinate system is illustrated here. As usual, you can insert the 0 point workpiece at any position. It could be the corners of the prismatic elements, in the middle, and so on. And let's put it here in the cases on this corner and press OK. So this is the 0 point workpiece. All the coordinates will be measured and analyzed, referenced to this coordinate system, this 3 coordinate system. Now it is time to define the workpiece itself and the blank of the workpiece. In order to do this, here we have the workpiece and double click it, and as a first you have to specify the part which was found, and click here this icon and select it is selected here, but let's delete this one, and here you see it is come to 0. And if you select this element, this workpiece as a part, here it will become 1 and press OK. And if you press here the display, you see your part will be displayed. So it means that this is the workpiece, and it is the final workpiece. Now let's specify the blank. In this case, you have to select this icon in order to specify the blank here. And if you see, we have the several options to specify our blank. In this case, it is this boundary block blank, and you see this, it shows the boundary block, and you can see here is the raw material boundary block, and here the coordinates is the point is the all is the 0 and it is the all is 0.3 in the all direction along the x negative, y negative, x positive, y positive, and z positive. And we will keep it is the 0 along the z is the negative because it is the fixed from the bottom to the table, and we couldn't make it a milling operation. We will just remove this all the overstock which is illustrated in this color from the sides of the system, or from the workpiece, and from the top. So always the 0.3. You have to be remember this one. So press OK. And if you press the display, you see it is illustrated the overstock of our material. Since in order to remove these ones and since it is better to use the called the plane milling. So press OK now. So we defined our coordinate system, we defined our the workpiece as well as our the blank. Now we will start the operation. In order to start our operation, as usual, we have to create a tool. And for the beginning we will make the face milling in order to remove this 3mm surface from the 0.3 millimeter from the surface of the system. We will make face milling. In order to do this, we will create a tool for especially for the face milling. So create the tool, select this one, and select here retrieve tool from the library, milling, and double click to the face milling, and it is in the inch. You can make it millimeter and press OK. Let's use this one, this 43 diameter, and you can display it. Press OK and cancel. So if you go here the tool machine view, you see here our tool is created, and you can rename it. So let's rename it for the face milling as usual, and as well as you can indicate it is the diameter directly. Diameter is the 43 of this tool. So since we created our tool, and we can create the operation, and for the face milling we have the special operation in the planar mill. Here select as a type planar mill, and which we have seen is the face milling with the boundaries, and you have to here set the location of your program. Here the NC program, in this case select the tool as a geometry workpiece, and the method we can obtain directly finish, and here let's keep the name of this operation just the face milling, and press OK, and you will be directed to another window of the face milling. In this case, as important things that you have to specify the face boundary. So specify the face boundary is this lower face, and here it should be the inside, and press OK, and we'll set other options for the tool. Tool is OK. Tool axis we will make it along the Z axis, and the method, let's make it finish, and cut pattern, it is better to make it a zigzag for this case, and percent of the flat diameter is let's make it 40, and blank distance was the 0.3, and per depth cut let's make it 0.1. so here let's define it is the spindle speed, and as you know it depends on your tool manufacturer, so you have to be careful this one, and you can calculate and press OK. So here we can generate our tool path. So you see the tool path is created in the zigzag form. Now let me double click here, and if you remember here, let me generate again. Here the overlap is too big. You can decrease this overlap in order to improve your processing time. In order to do this, we can here select the cutting parameters. Here let's make it 50 is enough, and press OK, and generate again. Now it's OK. It is in the zigzag form. So we can verify our tool path in order to see the result here. So verify. So here go to the 3 dynamic and decrease the speed. So plate. So this is the face milling. After removing the 0.3 millimeter from the surface of our workpiece. So if you see here, just a moment, let me again simulate it to see the other overstocks. Here you see this is the final product, but we have also the 0.3 the 0.3 the millimeter material which we have to remove it. So you see from the sides, because this is the light blue is the final product, this is the dark blue is the unnecessary part, we have to remove it. So 0.3 from the old side. In order to do this, we will use another operation, what is called plane milling. So in order to do this, for the beginning we will create our tool for this one. So we create Endmill for this operation. So it is better to use the Endmill here, or you can use this library to create the Endmill. So let's create the Endmill. So from the milling, so Endmill. So the let's press OK. Just see the available tools for the Endmill. In this case, we can use for example, let's make it 8 millimeter and press OK. Just cancel it, and here this is the mill is created, but let's delete this one and let's create Endmill in this manner, tool subtype, so to see the better. In this case, let's make it this distance is the higher. This is this distance is which means that is that fluid the fluid length. Let's make it 5. So let's make it 2, and let's make it 3, and the length let's make it 5. So and now it's okay, because this yellow is the 2 millimeter, I mean the 2 millimeters, I mean not 2 millimeters, 3 millimeters. This is yellow. So we have to just analyze, go to the analysis and measure the distance. I would like to measure distance from this one to this one. So it is the 2 millimeters. So this is enough to remove these faces in the one pass. So 3 is okay. Now we can keep it as 3, and we can create as a chunk for this one folder. So that's okay. So tool is created. This is the call. In this case it is the mill tool. We can rename it. For example, the right click and rename. We can use the profiling, profile Endmill. You can call it as you want, profile Endmill, and enter. So profile Endmill, this one. So now we will create the operation for this tool. In this case, select the create operation, and we will use here the planar mill. It is used for the operation which is remove the high portion of our material in which is the tool axis, always in the perpendicular to the surface being machined. So select this planar mill and set the locations. Check here select this tool which is created in advance workpiece. We can finish. So in this case we will have to indicate it is the cutting areas for the planar milling. So here we have for the beginning specify the most important is you have to specify the part boundaries here. Click this icon and here we will be directed to specify our boundaries. So in this case it is very useful tool. So this one, so let's make this is the mode with the curves and edges. So let's define it as the boundaries using the curves and the edges. So here let's make it, select here this one, this edge, and this edge. We selected these 4 edges, and here it is the closed, and here it should be, just a moment, I will go again here. So this edge, this edge, this edge, and this edge, and this is the border. But here it is showing the material. In the material is you have to select the inside or outside. It is the important. It means that this is the border. It means that if it is the inside, it means that the tool will remove the material which is the inside of this border. Now we would like to remove the outside material because the overstock is located outside of the border. In this case you have to select it is the outside, so it will be understand that we have to work on the outside of this border. And here you have to specify the plane, so the upper plane. It could be the automatic or you can change it is the by yourself. Let's make it user defined. So in this case you have to define the plane. This is the upper plane which is the work. In this case this is the upper plane. Select this one and press OK, and press OK again. So press OK, and if you press here the display, you see that this is the borders is the illustrated. And next important thing is to specify it is the floor. Here they specify the floor. Second important, most important for the planar mill. So you have to specify the floor. So select this icon, and in the case you have to specify the depth of your workpiece is the floor. In this case, if you would like to remove this surface, in this case our floor will be this face. So just a moment, this one. So floor is specified because we have to remove this side, and press OK. Now here you have to cut pattern. It is better to use the profile because we are making the profile path. Let's generate it. Alright, just a moment. I will select here again this one, and here you have to specify these cut levels. And let me just remind the distance of this step. So measure the distance. Let me measure the distance. This distance from here to here, not this one. So distance measure this one and this one is a 2 millimeters. So in this case let's make it here the 0.2, for example, the cut depth. Press OK and generate it. So here it is showing, but I think that it is a mistake. Let me just verify the toolpath, so then we can correct it. No, it is removing the other element. It is the mistake. We will have to correct it. Let's correct it. Let's delete for the beginning and create a new one. Create operation, the planar mill. So tool is the profile, press OK. Again specify the part boundary, the same. Let here the select the tangent curve, this one, this one, this one. It should be the outside, so press OK. So floor, this one, here the profile as usual, and here the insert depth, cut off the depth is 0.2. And the tool axis tool, let's check this one. Okay, tool is this one for the Endmill, and no, I don't know why it's selecting this one. Like I am doing, let's make it inside, but in this case okay, now it's correct, but yes, what was I was making the mistake is selecting here the material side. It should be the inside. Why the inside? The methodology is the same what I explained here. This border helps as the inside border if you select as the inside, since the inside, and it will be remove the outside of the material here, so it will be inside. So because it is the material is in the outside side, so a little bit I confused. Now it's correct, so press OK. If you generate it, you see the toolpath is generated by along the profile of the element with a layer. Each layer is 0.2, and we can verify the toolpath to see the result. So verify it, and here play. You see it is the removing. Now it's the profiling. Every step is a 0.2 millimeter. So now the workpiece is removed by the overstrokes with the upper and this sides. Now we will make this element to remove this element. So in this case we will use again the same function. It's the profiling. So profile milling. So for this let's create a tool which is the diameter is for example it is too high for this operation. Let's make it 0.5. so for this operation, so it is press OK. Now create operation again select the planar mill. In this case select the tool which is this one with a tool which we created last tool, so press OK. So I would like for the beginning to obtain this element, this pocket. So in this case again here specify the part, again it is in the mode select the curve and the boundary. So here it is the better to select the tangent and select this edge. So the edge is created. Now if you would like to remove this inner element, here our boundary, you have to specify it is in this case the outside, because if you select this is the outside, it will remove this inner element with the depth of this one. You can specify here the plane as a user defined. In this case the plane will this plane, because it's upper plane, and we will now specify it is the lower plane. The lower plane is specified in here in the specified floor. In this case this lower plane is this one. Press OK. and if you display it, you see it is the border, and it is the border is the here. If you go here, it is the outside, so it means that we will remove the inside material. So border will help us outside border, so it means that machine recognized to remove the inner one. So that this depths, let's I defined again the depths. So measure the distance between this one and this one is 0.25. here is 0.25. Why do we need these depths? Because here I have to define it is the cut level. Here it is a 0. If it is the 0, it will just remove this 0.21 in a one with a one pass. Let's make it 0.05. In this case, we will have the 5 levels. Press OK, and here the follow the periphery. Tool is what is the tool is here. Tool axis z-axis, and let's generate this one. You see, if you generate the tool path is only the created the inside of this one, because here we selected the border, and we are giving the as a border is outside border. It means that inside will be the machined. So here what we specified here, the border is outside, means that inside will be the removed. So we can see it, plate. So we only removed this pocket. Now we can go on the further steps. So to remove these elements, which is until this one, step by step, then we will remove this one. So for the beginning, let's make it this one, because now we will use the two borders in this case. So we will use the two borders for this one. Let's create again the operation. The same, use this planar mill. Here we will use the same tool. Okay, press OK. In this case, we will create the borders, two borders in this case, outer border and the inner border. For the beginning, let's create the outer border is this one. So here specify the part boundary. So here select this one. Again, go to the curve and edge. You can directly here select the tangent curve, and if you select here this one, you see the all is selected, and here specify that this one is outside border. So this is the outside border. So let me sync it outside, and so this is the outside border, and you can specify here the plane, the outer plane, this up plane here to this up plane, and press OK. Yes, press OK. Now see the outer border is created. It is representing here. Now we can create a second border, which is the inner. In this case, you will create here create a new boundary, new next boundary. So in this case, create plus this one, and here let's make it automatic, and here select in this case the boundary, which is this one. Here select the tangent, and this one, you see all is selected. This will help us the inner boundary. So in this case, select the material size as inner. So our boundary will be this inner, and this will be the outer. And here it is enough to make it automatic, because we already selected this face as a plane, and press OK. Now again press OK. So what we obtained in this case, if you press the display, you see here you will obtain here sorry, there is a mistake. Let me do it one more again, because with the selection it was the mistake. So don't worry. So I will first specify the boundary. Select the curve. Let's make it tangent curve. This curve, and define it as a outside boundary. And here user define it, and this one. Press OK. Create a new boundary. In this case, we will create inner boundary. Here, let's change it automatic, and select here the tangent, and select as an inner boundary this one. All is now is the selected, and here it is the inner boundary, and press OK. Press OK. So what we obtained in this case, if you press the display, you see here these two lines is created. The first one is this one, and second one is here, this one. So this is the outer boundary, and this is the inner boundary. So in this case, I would like to remove material between these two boundaries until the depth of this surface, from the starting from this surface until this surface. In order to define it is the depth, I will select here this floor, specify the floor of until this one. So select this one. So what we obtain in this case, we will obtain to remove the material starting from this surface to this surface. That is the boundary is this edge to this edge, outer boundary, the inner boundary. So you can hear the follow part. Okay, follow periphery does not matter. So here you see, if you select generate, you will obtain the toolpath, which is the between this is the what we selected as outer boundary, and this is the what we selected the inner boundary between these two boundaries. Here the layer is just one, and we can increase the depth per cut. In order to do this, I will again for the beginning the measure the distance. Here distance from here to this distance is 0.50 0.5. So in this case, let's select here the per depth cut is the 0.05. In this case, we will have the 10 layer of the cuts. I hope. So again generated. Now is to correct. Sorry, there is some mistake. Let's make it here the 0. So and generate it. Now it's correct. You see only the toolpath is here. So we can verify it, or verify the toolpath. So and this one. Now you see we obtained the depth until this surface. This is the outer boundary and inner boundary. And the next step is to remove the same material until this final floor with the same operation. We will in this case create again the two borders, what we have done in the previous step. So select the home and create operation. We will use the same tool with the 0.5 millimeter diameter here, this tool, because it should be fit here in this distance. Workpiece finished. So boundary, again specify the boundary, the same method here. Select curve and edge. Here select the tangent, and this is again there will be the outer boundary, and specify select this. You see it is selected, and specify it is the outside boundary, and plane in this case user defined, since we removed the material from until these faces, and we will select as outer plane, in this case this side. So okay, it is clear because we have to remove the material starting from this plane. From this plane to the here we already removed in the previous one. Press OK, and here create a new boundary. In this case we will create the inner boundary. So inner boundary is this one, this edge. So in this case select here the tangent. So select this one. You see all is selected. Here make it automatic again. Here it should be the inside boundary, outside boundary, inside boundary, and press OK. Now we will select again the floor, the cut of depth of cut. So here the floor specification. So this is the floor, the final floor display. So we defined it. So the same you can generate it. If you generate it, you see the just a moment. Sorry. Toolpath is illustrated here. Just removing material. Here you see that there is no toolpath since the tool is still big and does not fit on this position. In this case, let's change that the tool for this operation. We can directly change it in the operation. Here the tool, and here we can create a new tool for this operation, and select here. Okay, you see it does not fit. We can let's make it 0.2. Can make it 0.3. Let's make it 0.4. Let's make it 0.3. Okay, I think it fits. No, let's make it 2. It's okay. Now it fits directly on this side, so we can press OK and regenerate again. If you regenerate again here, you see here we appear the toolpath in all the sides, so we can verify the tool. So play it. Now we obtained the system. We can restart it and play again. So press OK. Okay. Let me again regenerate it to. So here you can see the result in the part navigator. Here the part navigator of the tools. That is the tool. This tool. With this tool we created as a face milling this operation. You see it is illustrating. I close it, and this tool with the profile and milling. And if you open here, it shows what operation is done with this tool. And if you select it one, you see it is making the profile operation, and you can close it again. And this mill. And this mill we obtained two operations. The first one is this one is illustrated, and second one is this one. Two operation, and last let's close it. With the last tool is this tool we obtained this operation. So up to now we did this option. I used these tools, and you see here we did this operation 1, 2, 3, 4, 5 operations. Now we will go on the further to make these operations. So step by step we will do this almost with the same method. So again we will create operation. We will use the same tools that we already created, because they exactly fits for these pockets. Create operation again, planar mill. In this case, we can use, for example, the let's for the beginning to see the result, then we will make change. So here again the boundary, it is the better to use the curve and edge. So tangent, select this one. I would like to remove this. So here the specify that this one is the outside. If we specify this outside, means that we would like to remove the inside material. If we specify that this is as an inside boundary, we will like to remove the outside boundary. Since we would like to remove the inside, so we will specify the boundary is the outside. So, and the user defined plane, the upper plane is this one. That's okay. And okay again. Okay. And the next step is to define the floor. Specify the floor, the depth. The floor is in this case we will first get this one. So, and here the follow the periphery we can select, and let's here the let's select analysis, measure the distance, select this face, and this face is the 1 inch. So we can here the cut level we can insert as a 0.1. let's make it, and it means that we will have the 10 layers for the cutting. 10 times 0.1 is the 1, so we can generate it. So you see the tool path is created only in this pocket. We can verify it. Now we obtain this one. Press OK. Now we will try to obtain this smaller pocket. So create operation. So in this case we will use the okay. Let's for the beginning create the operation. Now then we will create the tool as well. So specify the part boundaries as usual. Select the curve and edge. Here select the curve, for example this one, step by step to select all this edge. So it will automatically here the close it. So it will, let's make it open or let's make it close it. And this is the outside boundary, and it will be removed inside. Specify this plane. In this case the starting of the plane is in this case will be this one. Press OK, and again press OK. Specify the floor as usual. Here the specify the floor, this floor. Press OK. So we can create a tool for this operation because our tool is too high, too large for this operation. So here 0.1. So here also you can specify the tool material. So material in this case high speed steel. Here if you open here you will see the several tools for this one. As you know, in general for the Endmill high speed steel is used. Press OK, and OK again. Again here the follow periphery, it is the better, and make it generate. Only the tool is here the generator tool path. Let's verify it as usual. Here some material is removed, and we will see how to make it in the next lesson. So here if you move here here we have the planar profile. That means that making the wall finish and so on. Also we have the other functions, which is the finish the walls and so on, to make the finish the wall. So we can now go make here with the same method you can obtain this pocket as usual. So with the profile milling, so create operation, the planar mill. So here press OK, select the boundary, split the two, select as a tangent. This one, as usual, it is the outside boundary, and the user defined plane is the upper plane, this one. Press OK. Now we have to define it is the floor as usual, the depth of cut. Here the floor specification is this floor. Press OK. So let me again define the distance between this point and this point is the 1.75. Let define here the 1.02 in this case. Toolpath is created. You can verify it. Every layer in this case is 0.02 millimeter. So it is finished. Press OK and press OK. Here you see we have this all the steps, 1, 2, 3. Here all the sections, all the operations we have done so far, and finally we can as usual create the code, generate the G code using the post processor. So in this case you have to select all the operations like this, and here it is already the generate. If the toolpath is not generated, you can generate all the passes. Now it is the generated all the toolpaths for my cases, and here the select post processor, and you have select available machine in your workshop. In this case most used one is 3-axis milling operation, so I select here, and the unit is you can find here as a metric, and press OK, press OK again, OK. So it starts to generate the G code for this workpiece. Okay, G code is created with a series of the lines. So you can save the G code and upload it to your milling machine in general for the machine control unit using the heart. So and if then machine reads all the codes, then it will generate the product what we done here. The line is too many, so because we did a little bit complex shape here. So in this time that we can finish our lesson for today, and we will meet again tomorrow at the same time. Thank you for your participation and good luck for your exam preparations. So, is it everything is clear? The concept of the plain milling for today. You can try by yourself. Since I hope this element is not difficult to model. If you need, I will share as well as the model. If you don't need, you can create by yourself. So it is easy. So thank you very much for your participation. See you tomorrow.